Hi friends, welcome back to Unit 1, Day 4. This is the notes over complex numbers. We're on the back with operations with complex numbers. To find the product when multiplying, we just multiply like we would anything else. We just need to remember that when we multiply a real and an imaginary number, we end up with an imaginary number. When we multiply an imaginary with an imaginary, we end up back with a real number. So we'll see how we do this on this one here. I'm going to go ahead and set this up using the table method. I talked about this previously, but in case you forgot, so we're going to do the symbol in the upper left-hand corner, multiplication, 2, and then 3i go down here as my row headers, and then my column headers are 3, and then negative 4i. Then I just multiply 2 times 3 is 6, 2 times negative 4i is negative 8i, 3i times 3 is 9i, 3i times negative 4i is negative 12i squared. However, negative 12i squared becomes a positive 12 when we simplify. Remember, I squared is negative 1. If I multiply negative 1 times a negative number, then I end up with a positive. Now I combine all these. So I'm going to add 6 plus 12 plus 9i minus 8i, and I end up with 18, looks like plus I. So that is the product of those two multiplied together. This is a little weird. Usually we're used to seeing when we multiply these out, we're used to seeing like an x squared term. Remember that we just end up with a real and imaginary component. This is a complex number. Same thing for this one here. If you notice though, this is a minus b and a plus b. With this case, we should notice that we have something special that happens. And we're actually going to want to kind of hit this topic again. So I'm going to start this. We're going to actually come back and talk about this in the next video as well. If I set this up again using the table method, 3 and negative 4i. Then up here I have 3 times 4i. 3 times 3 is 9. 3 times 4i is 12i. I have negative 12i. And then I have negative 16i squared, which is really just a positive 16. So now if I add all these together, you notice my 12i and my negative 12i, those cancel out. So I end up with just 9 plus 16, which is 25. So I end up with just a real component, no imaginary part. And the reason we add that is because this was the conjugate of one another. 3 minus 4i is the conjugate of 3 plus 4i, and vice versa, which is really cool because then we can end up with just a real part. Again, we're going to see that later. This idea here, 3 minus 2i squared, similar to that factoring section that we did back in the chapter R unit, but kind of the same idea here. So we have 3, negative 2, 3, negative 2i, 3 times 3 is 9, 3 times negative 2i is negative 6i, and then negative 6i, and then let's see, that's going to be a positive 2i, so positive 4i squared, so that's going to be a negative 4. Okay, combine all these. Let's see, 9 minus 4 is going to be 5. Negative 6i minus 6i is minus 12i. So this did not get rid of the imaginary part like we did with the complex conjugate, so keep that in mind. Next, got 2 plus I radical 3 and 2 minus I radical 5. So again, multiplying these out. 2 I radical 3, 2 negative I radical 5. 2 times 2 is 4, and then here I have negative 2i radical 5. Here I have, let's see, 2i radical 3, and then here, let's see, negative I squared radical 15, because we can multiply underneath the radical. A lot of students get this part confused. They want to combine these two just because we've seen a combination of those two for each of these parts, but we cannot because they don't have the same term underneath the radical. It's close, but it doesn't quite work out. So we end up with 4 plus 2i radical 3 minus 2i radical 5. And then minus I squared, remember that becomes plus radical 15. And that is it. That is all we can do for this problem in terms of simplifying. All right. Join me in the next video where we rationalize I in the denominator and find out why. Have a great day.